Okay, we're on to section 2.8. How do you graph linear inequalities? I'm going to zoom in a little bit here. Okay, so we're all able to graph a simple line like y equals 2x plus 3. We just plot the y-intercept at 3, and then we go up 2 and over 1, because the slope is 2, and we draw our line. Okay, what does that line represent? Well, basically it represents every coordinate, every xy value that satisfies this equation. For example, negative 1, 1 is a point on this line that satisfies this equation to make both sides equal. 2 times negative 1 is negative 2 plus 3 is 1. Okay, so what about if we change that to an inequality? Y is greater than 2x plus 3. Now we're looking for all the coordinates in which that will satisfy having the left side greater than the right side. So x values that I can plug in that result in values less than whatever y is. Okay, so what we have is a graph that's similar to the one on the top. We still need this basic line, but then we need to somehow show all the data points that satisfy this equation. Okay, so if I was to graph that, again, let's get the graph on here. Now it's going to run in here. Now, one thing to keep in mind, every coordinate on here will not satisfy this equation, because the line satisfies this equation in which the left and right side are equal. Well, if the left side is equal to the right, it can't be greater than the right. Okay, so what we do to show that mathematically is we show a dashed line here. That indicates that all the coordinates on the line are not a solution. Okay, so the solution coordinates are either above or below this line. So what we do is we test a point. So we choose any coordinate here that's not on this line, test it. Usually the easiest point is 0, 0, unless it happens to be on our line. So let's test 0, 0. If I try 0, 0, I would have 0 for y. I'd get 0 is greater than 3. True? No, not true. So therefore, the coordinates on this side of the line, the right side, are not solutions, and the coordinates on the left side are. So I shade that side. This indicates that all these coordinates satisfy that equation. So let's just try a couple practice problems here. They're different varieties. So y is greater than negative 1. Let's try that one. Well, xy axis. Y equals negative 1 was a line, a horizontal line that went through negative 1. So in this case it would be a dashed line, like so. Now how would which side would I shade? Where are the y values greater than negative 1? Well, it would be above the line. Okay. What about x greater than or equal to negative 4? Axis, here's negative 4. So here the x equals negative 4 is a vertical line. Now because it's or equal to, it's going to be a solid line. Greater than or equal to negative 4 would be shading this side, because that's where the x values are greater than or equal to negative 4. Okay. Alright. Too easy. Let's try a tougher one. (2x minus 6y) is greater than 12. Okay, so now what we have is an equation that's in standard form. So if you remember, to graph that, we find our intercepts, and I'll bring them up here. Okay, so we're graphing at first just like there was an equal sign here. So if I substitute 0 in for x, what's y going to have to be there then? Divide both sides by -6. 12 divided by -6 is -2. Substitute 0 in for y there. That's going to get rid of that term. So 2 times 6 would be 12, so it would be 6. So those are my x and y intercepts. 6, 0, and 0, -2. So my line goes through those 2 points. Because it's not or equal to, it has to be a dashed line. So I'll bring my ruler here. Dash line. Now where do I shade, above or below? Well, let's try 0, 0 and see if it works. If I plug 0 and 0 in here, I can get 0 minus 0. Is 0 greater than 12? Nope, not today it's not. So we would shade. We would not shade the side where 0, 0 is, we'd shade the other side. Okay. Alright, let's try an absolute value. Get some more graph paper here. Okay, let's try this one. So, set up our XY axis. So when we graph absolute value, we find our HK, and we graph our vertex. So it'd be +2, +1. There's no number here, so the slope is 1, so I go up 1 over 1. And we flip that point over here. It's over equal to, so it's a solid line. Looks like that. So do I shade below or above? Well, let's try 0, 0 and find out. 0 is less than or equal to 0 minus 2 is -2. Absolute value makes it 2. 2 plus 1 is 3. Is that true? 0 is less than 3. True. So I would shade to the 0, 0 side. So that would be below. Okay. And let's try one more. So why don't you try that, pause the video, and then unpause it, see if you get it right. Okay, so let's see. This is what you should have had. Vertex of -3, -2 would be right there. It's also your line of symmetry. Slope is -1, down 1 over 1. Flip that over here. And it's dashed. Okay, try 0, 0, let's see what happens. 0 is less than, let's see, this would be 0 plus 3 is 3. Absolute value of 3 would be 3. This makes it -3. Minus 2 is -5. Is 0 less than -5? No, it's greater than -5. So I would not shade above this graph, I would shade below, which happens to be inside the V graph there. Okay, so that is graphing absolute value equations.